Before we get started, just a quick reminder. The organizer wants me to remind you, make sure you bring back your badge tomorrow when you attend. Otherwise, you might not be able to get in. So don't throw it away yet. Okay. And so for the afternoon section, we are going to get into doing some real analytic stuff. But I want to point out that what I'm going to show you, although it's like a little bit more than 2 hours, but it's only touched probably 0.1% of the Google Earth Analytics. So again, check the Earth Engine API, the user guide, it has tons of more information. But GMap, what we're going to show you today is to make it easier, right? With one line of code, you can do some like very useful, but it's very basic stuff in Google Engine. So again, we're going to go to here, section 3, analyzing Earth Engine data. So I know we have lots of content covered in this morning. If you're new, it might take you some time to digest. Again, everything is reproducible. Just go through the notebook, run through it, think about it, and then make some changes, and then it become your own source code. Okay. By now, you should know how to visualize data. So give you any raster data, any vector data, you should be able to filter the data to something you want, and then just look at it. So from now, we're going to start really analyze some basic data. And so the first one is called descriptive statistics. This is pretty simple. So I'm going to just run it, just show you. So I'm getting an image, and then I'm visualizing like, so this is a landscape image covering San Francisco. And the most basic like statistic is like, what's the mean value of this image? Like each band, right? You're going to have mean, maximum, median, mean, or standard deviation, something like that. This might be very basic if you're using desktop GIS. Like QGIS, ArcGIS, when open and then like mean value, this is not like easy in Google Engine. So it's not very straightforward. You need to use some reducer. So if you're new to Google Engine, I mean reducer is something that you need to actually to understand to be able to get some analysis done within this. So first I'm going to go through this couple examples. It should be pretty easy, right? Give an image. Now there are some functions. For example, the property names is like, if you go to the Earth Engine website, you can see the image properties, like what's the band, so the property names, you can look at all the metadata information, but this one doesn't give you the values. It only give you the name of the property. But if you use the to dictionary, this one give you not just the metadata, the property, but also give you the value, right? So if you want to see, for example, what's the cloud coverage, you can get that from here. So this is where you can quickly get information. And most of the time, if you're doing like programming coding, you need to get some property. So you can just image.get something. .get is to help you get the property. So for example, cloud cover, right? You can look at here, cloud cover 0.05%. Keep that in mind. Everything you can do is just by looking at it and the output. That's not the whole point. If you're doing programming, you need to minimize the requirement of interacting with the map or looking at the output, okay? You need to make things reproducible. Just like the notebook I'm providing here, if you run it, you get the same result. I don't have to ask you to click this button, click that button. It's minimize that, because if you develop something, everyone is like clicking things differently, you might not get the same result. So if I get a cloud cover, rather than ask you, okay, run this one and then look at the first line and then look at that, just .get passing and then you get the value, right? So for example, you get a cloud cover, it's 0.05%. So right now we're not doing statistics yet. We're just getting what's already available. And you can get any other attribute from here. So, and this can be useful if you're writing a program, you want to filter the data to specific like cloud coverage. Then you can get, and then you can pass in, you can write a function, for example, give you 100 images, filter to cloud cover less than 5%. But certainly Google Engine already has those functions. I'm just giving an example that try to develop code that's reproducible, that the user don't have to like change a whole lot of things. Otherwise, it's not like very efficient. So next one here, or you can also use the image props. Image prop, kind of similar to dictionary, except that the image prop convert, I think, the system start and end date to something readable. Okay, so Google is saying if you go on image, all the image most likely the system time start and system time end is basically the acquisition time of the image, but it's not like easily understandable because it's the number, a huge number, the seconds since 1970 January 1st. So it's like a long number. So sometimes it's like, okay, I want to see what's the acquisition date. Then you can just use Gmap function image_props, and then you will actually convert all the dates into easily understandable. So this one, for example, is 2013 April 9, right? You can easily understand. So this getting the image properties. So the second one here, image stats underscore. So this is basically where the descriptive statistics. And if you click the object, it's going to show you max, mean, minimum, standard deviation, and sum, right? So this is where you actually, so you give you an image, it's a Landsat 9 image, or Landsat 8, whatever, and then you have multiple bands. So here, it only shows you the property. And this one, you might look like simple. Under who is like calling the reducer is like a couple lines of code. It's not very straightforward for beginners, like how to, I just want to get a mean value of this band. Why I have to write so many lines of code? Like desktop.js can just right click open. It's cloud, it's server-side object, so it's not something like very intuitive. So you can always use the image stats. So earlier this morning, like there's a question about how do I figure out the mean and the max to put that into the visualization. You can run this function to give you a rough idea, so they can quickly know this band has like minimum, maximum, something like that. So this is just one line of code, give you some basic statistics about what's the minimum, what's the maximum, what's the mean, standard deviation, something like that. Questions? Easy, right? One line of code, most of the things. Next, let's talk about zonal statistics. So this is a very common GS operations, and it's super useful. I want to give you a, for example, user case. I give you, for example, a DM, right? And I also give you like a state boundary for the United States. And right now, I want you to tell me which U.S. state has the highest average elevation within the state compared to others. Any guesses? I can load the data first, right? You can, right now I'm not going to go through all of this. So right now this is what I'm showing you here, right? Giving you a DM, giving you a vector data, just tell me which state has the highest mean elevation, right? Taking all the pixels within the boundary and then calculate, right? If you can see that from the map, if you have to guess, which one? Colorado, right? Okay, cool, right? It's easy to see. How about which one has the lowest mean elevation? Any guesses? Louisiana? What else? Florida? What else? No correct answer so far. Texas. Right? It's not very straightforward, right? This is where you need to do statistics. It can show you like quantitative results, like, and not just for like elevation. I can ask temperature, right? I give you a temperature image. Just tell me which state has the highest mean temperature, right? For a specific day, for a specific year, whatever, right? So once you have data, then this is where we need to do statistics. How many lines of code? One line, okay. Zonal statistics. If you use JavaScript, there are many more lines you need to write. So this one, we're basically saving the result as a CSV, and it's just one function, zonal statistics. So if you don't know how to use it, Shift tab, right? So in value raster, I give you a raster and also give you a vector, basically the zone. So basically the raster and vector. And given that, you just tell me where do you want to save the result to. And the statistical type, you want to calculate the mean, or you're going to calculate the maximum, or you're going to calculate whatever. So it can be, for example, population, income, whatever. Just one raster and one vector, right? And then just do the computation based on each polygon. So in here, just one line of code, and then run it. Less than 1 second, you get a CSV, boom, right? It's done. Right? If you have to do that, like using desktop, download the entire DM, several gigabyte, and then you need to have some computing power to do it. So it's done here. I just open it, right? Get the mean, this column, and then the state. Scroll down to the right. You can see the name in here, right? Which column, right? And so this is how you get a zonal statistics. But this is not sorted, so it's like probably random. And if you want, you can, where is it? Yeah, so there's a function CSV to DF, basically convert it to a data frame. If you know how to use pandas data frame, you can do that. But just one line to read the CSV as a panda data frame, and then sort the value by the mean column, and then ascending equal to 2, basically from the lowest to the highest. Okay, so now you see this data frame. Okay, of course, you scroll all the way to the right to the end, right? 2,000 mean elevation 2,000. Which one it is? There's supposed to be a scroll bar. It doesn't show up in here, but you can see from this column here, right? This column, where's my mouse is, ST-USPS, right? And so the top 3, okay? Colorado, Wyoming, Utah, okay? So those are the highest. Again, what's the lowest? Right? I scrolled it if you pay attention. Huh? Delaware, what else? This one I think is Mario Island, something like, and then Virgin Island, Florida. What's this one? I forgot the name. Okay, here on the right column. Yeah, so those are my, like, it's not something like very common, like you know, but this is based on quantitative information, right? I calculate and then give you the result, right? That's one example. And later you can, there's an exercise showing you how, asking you to calculate, for example, what's the average highest temperature at a specific day for the US, right? So, what zoom level was used to calculate this? Oh, that one is based on the, you can specify it, but by default it's using the native resolution, but you can, so I'm showing here, shift tab, and there should be a scale. So keep in mind here, Google Engine is so powerful, but for the computation, sometimes you might want to use a low resolution, because otherwise trying to fit the native resolution 10, this is not 10 meters, 30 meters. Sometimes the memory is not enough. So you can either specify scale, or Google Engine can use the optimal scale that it doesn't exceed the memory, but use the base resolution is going to calculate. But if you want to be precise, I can specify the, like here, scale equal to, for example, 30 meters. But you need to keep in mind, it might not allow you to do that. So it's better to just don't specify unless you need something very precise. Then you specify, for example, I want to calculate at a 30 meter resolution, 10 meter. But if you're trying to do 10 meter for the global scale, most likely it won't work. Oh, there's some of the function, the reducer and like reduce reason, they have a base effort equal to 2. So base effort equal to 2, basically Google is going to figure out what's the base for you within that limit. And so that might be something you want to consider. But I can try 30 meters, but it's going to be a little bit slower. But this is just more like, we don't need very accurate, we just want a rough estimate. So it's fine to use the, whatever Google is saying, say, this is good enough. It's doable within the memory, right? So this is one simple example doing one band and for the elevation. But I can do multispectral bands, so it doesn't matter. So it's the same here. The second example I'm going to show you. Let me comment out this one first. All right, so I have the elevation, but here I also have another data layer. It's the Landsat data, okay? So I can add a similar example. Calculate the mean DM value for each state, right? So within, for example, within Texas, you have B1 all the way to B7, right? Give me the mean value for B1. Give me the mean value for B2. And this is just using the temperature, but you can imagine I can give you a time series temperature data. So I can give you temperature every day. So just calculate, let me know the maximum or the mean temperature for each state for the past 30 days, or for the past year, for the past decade. It doesn't matter. It's just a time series. So you can have an image collection and then convert the image collection to an image. Use the collection doc to bands, and then you get the image, And once you have that, you can treat the image as a time series, and then you can use the same zonal statistics in here. So here, what we're doing is given an answer image, give me a state boundary. It can be country, it can be anything, and then calculate the mean value of each band in that image. You see, it's done, and refresh. Lane set. See this? B1, B2, B3, B4, B5, B7. See that? Simple as that. And so for each band, right? So right now, for example, I want to ask you like which US state has the highest mean reflectance in the near infrared band, right? You can do that. So just use your imagination. There are so many applications that you need to do this. So for example, if I give you population density data or population count, whatever, and tell me which US state has the largest population. Then you use the sum, or you can use mean, or you can use standard deviation. So what you need to do is basically in here, statistical type. It can be mean, it can be max. So look at the documentation, and I think it's under statistical type in here. So mean, max, some of the commonly used ones. So you can also do standard deviation. So I can ask the question like, which US state has the terrain is very rocky, right? Compared to the very flat, or which US state has the most flat terrain, topography. Then you want to use the standard deviation, right? So the lowest standard deviation is really flat, right? So which US state has the terrain is the most flat? Which one? I don't know the answer. You can try it out. I'm just like those are examples you can do it. All right, so that's one. So next, let's do another zonal statistics. So we give an image, give you a vector, but now let me show you another application. So here, I give you a lane cover data, I give you the state, and I can ask you a question, which US state has the largest agricultural area? Can you tell me on the map? Which one? Iowa? Yeah, maybe, right? It's pretty, so the brown color is the agriculture, right? That's pretty relatively easy to see in my last area. If I ask the question like in the other way, which US state has the largest percentage of agriculture compared to its land area? Then it might be less obvious. It's not the absolute, it's the relative, right? The agricultural area, for example, within Iowa divided by the area of Iowa. Right? Is this a simple question? Yeah, you can find out, like, again, one line of code, you can do that. So if you scroll down, here, the same thing. So this one is called zonal states by group. I'm asking you temperature, agriculture. I can ask you the other one, forest. Which US state has the largest forest coverage? Arkansas? Like forest is like dark green color here. Right? You don't have to guess. Just run it. You get the result. That's right. So here I'm just going to run it like zonal states by group. Again, give me an image, give me a vector. Where do you want to save the result? And this one is calculate the sum, so basically the total area. But you can also calculate the percentage. This one might take a little bit longer, and you can also specify what's the denominator. Basically, by default, the area will be like square meter. So denominator means you can divide it, for example, by 1/6, basically 1 million. So convert from square meter to square kilometer. So the outcome will be give you a table, and then each one going to give you, each lane cover will give you some results. So let me show you the data. You will see what I'm talking about. So here, this is the final result. You will see class 81, 71. It's kind of random because when it's doing the calculation, the result is not like from 11, 12, 21, but you get all the classes in here. For example, 81, 71, 82, right? So 82 is agriculture, right? So I can scroll to the right. You have all the classes. So this one is different from the elevation, right? You only get one value for one state. This one, because it's lane cover, so you have multiple type. And this one basically gives you, for example, for California, what's the area for water, what's the area for agriculture, whatever, like for all the classes, you want to get one value for that, right? So if you see from here, like from 11 all the way to 95, right? So with that, I can just, for example, read it as a data frame. So now you see If earlier I asked you, like agriculture 82, right? So which one? Here's the highest. If you scroll all the way down, there's some zeros here, so the ranking is not right. So it should be the third one, right? This one here. Jupyter is weird, so it doesn't have the scroll bar in here. But let me open this one, NLCD, scroll to the bottom, and so 80, 82, the third one. Did you? Oh, it's not ran alphabet. Let me do it here. So what you can do, maybe just so you can select like just a couple columns. Let me see here. I will just class 82. Right, and then I can do another one here. ST USPS, right? I'm not forgot the name. What's the name of the column? Name, okay. Or SPS. So I'm just going to put here. Oh, there's this one is wrong here. I think it's right here. Okay, now it's better. So here, but it's not sorted, so you can doc sort. I'm going to come back to this one. Steal the code here. Right. So what we're trying to figure out is like you can use any classes you want and then just sort by the value. So in here I want to sort by class 82. Right. So now if you're trying to look for the largest one, so you'll be ascending equal to first. Okay. Iowa, right? Top one. Top two, Kansas, North Dakota. Okay, and then I can ask, like, you can do the same thing right now. For example, urban area, like which U.S. state has the largest urban area? Say it again. Oh yeah, you can, but there's a way that you can put all the labels, but we don't do it in here. So Earth engine is not, it's like cloud object, so it's not. But there's a way you can add a label to that, but
not inside the polygon, right? Not yet there. We're not yet there.
Say it again.
Like not inside the polygon. We can't label.
Yeah, it's a bit convenient. You can do it, but it's not. There's a map.addLabel function allows you passing a feature collection and then put on the labels in here. Let me see if it works. If you really want to try it out, so it'll be m dot what's that, add label. It may not work, okay? It's dangerous to do things on the fly. But add labels, and then there's here data column. Okay, so the data will be this state. Okay, I'm gonna show you here state, and then the column will be I think it's STUSPS, so it's a standard STUSPS. It might, okay, it works. Okay, see, it's good. So now you have the label, right? It's black color, but you can change it. So it certainly it's not perfect because it's actually acting a point, and then it's using IPy widget, so I can customize here. For example, font color equal to maybe red. So equal to red, or you can use any like hex color code. It should work the same way. Okay, but this is not recommended if you have a large vector data. It's going to pull the data, and then it's not very useful. So you rather, but it's certainly possible. The color doesn't look good, but you can maximize it. You can do it, but you see the point. So here, earlier I mentioned, like, for example, agriculture, but you can do any type, right? So whatever class, for example, if I'm looking at let's say evergreen forest, right? 42. So now I'm basically coming here, change this one to 42. Okay, 42. So any guesses? Which one is the largest forest cover? Let me turn this one off on this. Which one? Washington. What else? West Virginia. Yeah, you don't need to guess. I'm just going to run it. Then you can see the result. So here, where is it? Yeah, I already have here. So I'm just going to run this code block, like 42. Oregon, actually Montana, California, right? We have one out of 3 is right. But you get the idea. You can do it for anything. So lane cover, like income, different categories. So basically, if you have an image, there's a categorical data, 1, 2, 3, 4, whatever, and then you have a vector data. Then you just put the two data layers together, and then the result can be returned as this. Question?
Yeah, but how do they deal with no data? Because I didn't see any.
No data is not counted. So no data is no. It doesn't treat it as a pixel.
So it automatically
But
knows
it's up to you. So you can, like, before you put the data into the function, you can use Google Sending, for example. If there's no data, you can change to 0. It's up to you how you want to do that. But by default, if there's no data, it's not counted. So it's not used in the calculation. So this is one way you can do the save the result as a CSV. But sometimes you might want to calculate the result and then passing the result to some other computation. In that case, you don't want to save it as a CSV because the data is outside of Google Sending. Then you cannot. You can put it back when you need to upload. So if this is the case, you want to, here at the bottom there should be a parameter called return FC. So if you want to keep the data within Google Sending, you want to save the result as a feature collection rather than as a CSV. So in here, I can just pass in return FC equal to true. Then you can save the result. For example, I can say result here equal to something. So in this way, it's just showing the computing, but it should be, if you display the result, it will show you. So I can here, for example, the result would be a feature collection now. And then I can just talk first, right? I can show what's the first one. But again, if your polling is very complicated, like a lot of file, it's not good. But see here, right, feature, properties. You see these are all 0 because of just that island or something like very small. But you can also use this. I can do gmap.ee to df, and then I can show you, for example, the first result.limit. I'll just show you the first 5 rows. Right? But right now, I'm still showing you the result. It's still converted the Google Sending feature collection object to the local client so they can see. But everything is in that variable. That result variable is a feature collection. So that one is still Google Sending. You see, now I can still, the result looks like this. I'm not sure if something wrong or not. But anyway, just return FC if you want to keep the result as a feature collection. If you want to get it out, then you just save the CSV. That's it. And then you can use data frame to do all kinds of things. And so that one is using the sum. You can also, for the zonal statistics by group, there are 2 types. You can either calculate the total sum, or you can calculate the percentage. So the percentage means I'm going to calculate the area of each lane cover divided by the area of that state, that polygon. So that answers the question, for example, which US state has the highest percentage of agriculture compared to its total area, right? Is it 70%, 50%? I'm not saying about the absolute area because sometimes you want to see the dominant. For example, if I ask you, what's the dominant land cover in California? Anyone? It's hard to tell, but you can guess. But you can always use this like percentage, right? Get the result, and then I have that, and run it, right? And I can open the statistics percentage, right? So this one gives you a number in here, right? Each lane cover, right? So what we're looking for example, if this evergreen forest is 42, right? And you can see like 2%, 18%. You can scroll down. You can do the sorting, and then you can get the states, right? So they give you most of the time. After you do generate some image and you have some vector, you always want to calculate the sum, the percentage, or something like that. So this one line of code, and it doesn't matter if your image is global scale, is continental, or it doesn't matter how many polygons you have. So right now it's by state, by country, right? It can be. It doesn't matter. So more important is the concept. What do you need to use? So this is zonal statistics. is one image, continuous value, calculate the mean, maximum, whatever. Statistics by group is usually length cover or different categorical data, and then give you a vector, and then calculate what's the composition of that within each state, okay? And that's pretty much it. Those are very common functions. And the next one to show you is still zonal statistics, but let me show you what application it is in here. So I give you a DM, and I also give you a length cover data. So can you tell me which length cover has the highest mean elevation? Which length cover has the highest mean elevation? So basically, which length cover type is at the top of the landscape? Which one? Slopes. All right, we can find out. So it might be surprising, but you hear, just one line of code. This one is called image states by zone. Kind of similar to image states by group, but right now we are dealing with two images. We are not dealing with two vectors. Of course, you can convert the raster to the vector, but it's like usually a lot of memory, so you're going to time out. So what this one is doing here is you have the length cover. I get one length cover type. I do the zonal statistics with this DM or the whatever, and then get the result and do the second one. So it's more like kind of like looping. But let's take a look. So here I run it, give you the mean, and take a look. Which one? It might be hard to tell, but you can like do the sorting. So let me see here. To CSV, so this one, like the statistics, that one is what's they called? It's what I'm trying to do here. I'm trying to calculate the mean elevation of each length cover, right? So what I'm doing is we need to do the sorting. So I'm going to here, dog sort values, and then I'm just going to be by the state, right? And then just run it, okay? So this is like ascending. I can just ascending equal to false. Ascending equal to false. Okay? Which one? Class 12. What is class 12? Okay. Is this surprising? Perennial ice and snow. Right? Does it make sense? Does it make sense? Yes, right? It's on those mountain top, those ice and other stuff. Right? So no one gets it right. It's like surprising. But this is what we calculate. We figured it out and quantitatively. How about the top three? I already showed you the result, right? Do you remember what's the other two? Top two and top three? Okay. 12 and 21. Oh, is it? No, this there. Oh, here. 52 and 42. Okay. So 52, yeah, swap and scrub. And what's the other one? Oh, 42, right? Evergreen forest, right? Kind of makes sense. Again, you can generalize it to any other application. So at any time, if you have two images, and one is categorical data, like different types, and the other one is like just continuous whatever, you can use that to do statistics by category. Okay. So those cover the mostly basic one. Let me see if there more here. Yeah, it's the same thing. For example, I use the reducer using STD. STD means standard deviation. So this one answers the question is which lane cover, the topography is like some are flat, some are very rocky terrain, right? Which one has like most rocky terrain in this one? So you can do the same thing, get a CSV, and then you can do it, right? So you can figure out which one in here, 60, 300, which one? Probably this one, right? Forest, right? 42? Yeah, forest lane cover, like the terrain changes, right? Because the elevation. Yes?
Can you do also like 3 images?
Say it again.
Can you do also 3 layers? Like now we're doing.
No, this one is only one layer, but you can certainly write a loop to do it multiple. So the category code is one layer, and then the image is just one layer. You can do a repeat, but yeah, just do it multiple times. You can create a map function if you want to do loops through that. Okay? Yes?
How different resolutions are handled? So for example, if land cover is
Uh-huh.
100 meters,
Uh-huh.
now the layer is 1,000 meters.
Yeah, you can, I believe you can also specify a scale here. Do the same thing. Let me see here, shift tab. there's a scale. So everything you can control specifically by scale, or you just let Google Sensing determine which the. Yeah, it's quite complicated, but unless you have very precise about the projection, most time you don't have to worry about. Google Sensing take care of them all because you can figure out how to do the projection and then how to do the computation. And that's the power of using Google Sensing. You don't have to worry about projection. You just all align on the map, and then when it's doing the computation, it also will be able to do that. But projection doesn't really matter until you try to export the data or you're trying to do computation. If it's just visualization, you just let it like deal with it. Yeah. Any other questions? Okay, so now comes the exercise 3. I already talked about this, right? Give you your temperature and give you a polygon, right? Just tell me which US state has the highest temperature on that day. If you have to see that from the map, right? Which one? Texas, right? Or what's the lowest one? Mean elevation, mean temperature on that day. What's the coolest state? Okay, then you have to figure out. Okay, and I'm gonna give you 5 minutes and see if you can figure it out. I have the feature collection here, the image collection here, and you can filter by date. Yeah, so give you a couple minutes and then you can do it. If you cannot do it, that's fine. I will show you the answer keys later. So what you need to do is to filter the image collection to the specific day of the image, and then just zonal statistics. So this should be like 2 lines of code. If you don't want to visualize them, it's just 2 lines of code. If you finish, raise your hand. I'm giving you a surprise. Finish? Okay, awesome. You see, less than 2 minutes. It's done. Okay, I'm going to show you to save some time. I'm going to show you the result. Okay, let me move slowly so I don't expose all the answer keys. Okay, a lot more than 2 lines, but in terms of visualization, get the color bar and other stuff, so you can do it. But essentially, it's just 1 line of code. Zonal statistics, passing the image, passing me the state, and the temperature, you get the mean, that's it. So let me copy here, and paste it here. And add a new code block. And you can do the sorting just like we did earlier. So basically convert to a pandas data frame and then just do the sorting. Yeah, so most of the code above basically is just filtering the data, visualizing the data, set up the visualization parameters, and then add the color bar. But most of the things is 1 line of code, and the key things is the zonal statistics. So it doesn't matter, is it a temperature, is it forest cover, whatever. It can be any images. And then, so it's a vector, raster, okay. All right, so that's about the zonal statistics, okay. We only cover 3 functions, but there are a whole lot more. in Google Sensing. And next, I'm going to show you how to create, for example, some coordinate grid. This can be useful if you want to do analysis by grid or whatever, or if you want to export the data, a global image. Right? Sometimes you have to subdivide into smaller pieces, so you can do that. So this one is called latitude grid or fishnet, whatever you want to call it. Right? So sometimes you want to do analysis horizontally, or you want to do analysis vertically. And this is very common, especially, for example, you are doing temperature. You want to show the temperature changes by latitude. Then you might have to create like a latitude grid, and then you do the zonal statistics, right? They say, I give you a temperature. I give you a temperature image, and I ask you to create temperature changes according to the latitude, right? So how do you do that? I can do like every latitude from 0 to 1, 1 to 2, right? So in that way, if you create a fishnet like this, and then just use the zonal statistics, passing the temperature and passing this one, you get it, right? And you get all the numbers, and then just create a plot for that number. 2 lines of code, right? So if you have to do that, like using desktop, you're going to say, how do I create this vector data? It's going to take you some time. This one is only 1 line of code, so it's a feature collection, and then just edit. You can also do it using longitude. So if you're doing some longitudinal analysis, you want to do it like, for example, every 3 degrees, something like that, you can create this also easily. And the last one is like Lat-Long grid, is that you want to create a rectangular grid, right? And it can be sometimes quite common. You want to calculate some kind of statistics based on this kind of grid. You can customize it. For example, here you can pass in the parameter. So this is like 10 degree latitude and 10 degree longitude, right? You can change it to 5. You can change it to whatever number. The smaller number, the more you're going to get. So this one basically shows you how to create a grid, a feature collection. Next one is like a fishnet. It's more like if we give you, for example, give you a country, give you, for example, US. I want to subdivide the US into evenly into like 100 pieces, right? And I want to calculate some statistics within those. You can do it like this. So let me run this one here. Right. So for example, I want to do analysis based on this area, but Google Sensing doesn't allow you to do all at once. The memory is too much. You can do it like one small piece by one small piece. So in this case, we calculate, create a fishnet. So gmap.fishnet, and then just passing the geometry that you want. Then you can specify the horizontal. For example, I want 2 degree by 2 degree grid. And let's just run it then to see what it looks like, right? So take a look at this one. I give you a rectangle. I only subdivide 2 degree by 2, 1 by 1, whatever. And you can easily subdivide this into smaller pieces. And then you can do zonal statistics based on this grid. So this is one. You can do it for another one like this. So for example, here, right, my area looks like this. Again, I have to subdivide evenly into smaller pieces. Then you can do the same thing using the fishnet. You see, so it's going to subdivide your area, like intersecting with your area, but it's evenly the same size of grid. And this might be useful if you need to export the data, or you need to do some statistics based on this small grid. I don't have time to explain all the code, but you can digest it later. I'm more like giving you an idea of what it can do. So next time you need to, I need to create a fishnet, or I need to create a coordinate grid. Yeah, use Gmap. There's one line of code. Yeah, it's that easy, right? So that's about some of the things. So next, I'm gonna cover how to do some real analysis, right? So earlier I showed you how to do some zonal statistics, but how do you actually start from scratch, right? How do you load the data? How do you analyze the data? How do you, we have some existing, for example, for discover data, but you are welcome to do classification. You can create your own data products, and then you can start doing zonal statistics. So in this specific example, we're going to use the Hansen forest cover data from 2000 to 22. So this is just a single image with different bands, and there's the name of the band. So the first band 0 is like tree cover. 2000, basically in 2000 was the tree cover, and so it's like the percentage of tree cover in 2000 and then loss and gain, basically what year was that forest lost. Okay, so if this 2000, for example, the first image is like 2000, so if the forest was lost in 2001, then the lost year would be 1. Okay, so basically the year minus 2000. So for example, the forest was lost in 2013, then it's going to show on the image as like 13, basically minus by 2000. And it also has the original image, like B30, 40, and 50. Basically the, what's that? Green, red, and near infrared. So basically the original image. I will show you the image, you understand later. So for here, I'm just going to create a map, and then I'm just going to select image in 2000. So basically, this data set contains data for 2000 all the way to 2022. So you have the first image at the beginning, you have another image at the end, and in the middle, it shows you each pixel when the forest in that location was lost or was gained, basically new forest or something like that. So this, like, one is code block, and I'm going to show you what does this mean, okay? So here we have 3 data layers, right? They're simple. Okay, this image I'm showing here is Landsat 2000, okay? And then we have Landsat 2022. We also have the tree cover. Tree cover, this one is in 2000. So basically what this one is doing is giving you, basically based on the Landsat 2000, delineate the land cover for this image, okay? And then they do land cover change, basically for every year, they do analysis and figure out whether that forest pixel is still there or not, okay? So here you'll be like, this is the original image, and this is the tree cover. I can use the opacity. Right, kind of makes sense, right? It's just like the tree cover based on whatever algorithm they use, delineate the tree cover. So the green area are the trees. And so if I uncheck this one, you see the tree cover is from 0 to 100. So basically the percentage. So each pixel, if you zoom in here, it's going to show you that pixel. If it's like dark green, that means it's like higher percentage, so it's more likely to be forest. The black area is like not forest. But if you want, you can inspect the pixel values. So I can click here. It's going to show you this is like 100%. If I click the dark area, it should be 0. But it should be somewhere in between, right? So not all the pixels are 100. So if I click here, this one shows you 50%, right? So the forest, usually the definition is that if the cover is more than 10%, it's considered as a forest pixel, right? So if I click somewhere here, this 128 is still considered as forest. But basically, original data and the forest cover, right, 2000. Now let's figure out, for example, which country has the largest loss of forest during the past since 2000? Brazil? Okay. What else? How about the top 3? Russia? What else? Russia, Brazil, Indonesia, Canada? Yeah, we will figure out very shortly. On the other side, which country has the largest forest gain since 2000? Costa Rica? Germany? Yeah, I don't know the answer. We'll figure it out. So here, right now, we have these 3 data layers. And think about here, the first thing we can do is to extract the forest, right? By default, this data layer is 0 to 100. But we want to get a binary, right? Yes or no. Is it forest or no? So we use the threshold, for example, 10%. So if that pixel, the probability cover is larger than 10%, we treat it as forest. So eventually, we're going to have a binary image, yes and no, 0 and 1. So this is pretty simple in Google sensing, right? This image, GT means greater or equal than, and then the threshold means if this greater or equal than 10, I treat it as yes. There's a last one here called self-mass, basically mass outloads 0. And then in that way, we only have area for 2. And then I just add that to the map. It should look pretty much the same like this one, except right now it's a binary image, looks like this. So it's either yes or no. So there's no probability. And right, if you're over there on top of this one, it's hard to see, right? But it should be pretty close to the original image because they were delineated based on that. I probably need to use a red color or something else. It's probably better. But anyway, right now, like this is the tree cover at the global scale, right? And any pixel greater than 10%. This is probably overwhelming, like it's all green, but that's based on the data, okay? I'm not saying the data is perfect. It's never perfect. So these global scale products, it looks nice when you zoom out, but when you zoom in, there are all kind of problems. You expect that. But using this example, now we can do some statistics to figure out forest loss and forest gain. So let me run this one first, just to show you. So we add the base map, and then we select the loss year. So loss year basically means when was that pixel of forest lost. So the value is going to range from 0 to 22. Right? So if it is lost in 2001, the value will be 1, 2, like all the way something like this. So here we have the loss like 0 to 22, and then yellow and red. So yellow is represent lower value, red may represent high value. That means, okay, if the forest was lost in the early days, it will be yellow. If it lost more recently, it will be red. Right? So you can clearly zoom in to see here, right, a bunch of those in Canada, in other countries. Right? So again, if this yellow, it lost a long time ago. If this red, it's more recent. So again, you can use the inspector even to inspect like every pixel. So right now, what it's showing here, that means this is forest loss area, and the forest is no longer there. It was lost like 17, right? So that means it was lost in 2017, something like that. Or the yellow color, like 1, that means it was lost in 2001, something like that. So with this information, now you can start thinking about, right, okay, go back to the question that I asked earlier, which country has the largest, for example, forest loss during since 2000, right? So take a look at this one, add the data layer, forest gain, forest loss, self-mass, and then red, and then yellow. So this is like a little bit more. Is like right now we separate the loss and gain into 2 different data layers. So let's look at the loss, right? These are all the forest loss because you can do the statistics if at any time during the time span, if it is already lost, then it's considered as loss. And you can see here, right, a lot of red color. But the forest can lose and then can come back again. It happens, right? But right now we are simply focusing on this data layer. Like basically during since 2000, at some point, the forest was lost. It was no longer detected as forest. So right now I can zoom out here, right? Okay, so which country has the largest forest loss? Hard to tell, right? It's just all red color everywhere. But you can simply, for example, I get a country, I can load the country on top of the data, right? So these are all the countries, just a simple example. And then, just one line of code, zonal statistics, right? Our favorite statistics. So give me a tree cover, yes or no. This one is just doing like, we are not talking about the loss yet. We are just talking about the forest cover. So we are talking about which country has the largest forest cover, not forest loss yet, right? Based on the 2000, based on the image 2000. And then let's take a look, right? And you see it's less than 1 second, so we get the result. And so here is, let me refresh, right? So it's the forest cover. And the sum is the total area of the forest for each country, right? So we have the country vector in here, so you can scroll to the right. And again, you can do it, the panda data frame, you can do the sorting. But it'd be nice to just create a chart so that you can see, for example, in total, what's the forest in the US cover, what % of the total global forest. Let me just run it to show you more visual, okay? See? Which country has the largest forest cover in 2000? Right? Russia. And then the like others, like 22. There's the second one. Canada. Brazil, right? Isn't it nice, like just a pie chart? If you want to, for example, I don't want to count the second one, I think you can just click here on the legend. You can hide it. So now if you want a specific country, so the first one would be Russia, Canada, Brazil, USA, China, and like that. So those like the day the forest cover in 2000. So you can use gmap.pie chart and then just pass in the CSV and give it the name, what you want to show up in the legend, and then give it the value, which one you want to map. Okay, so it can be whatever area, or as long as a number, you can do it easily. And you can specify how many rows you want. Well, this is basically 20, the top 20. So I'm showing you the top 20 countries with the highest forest. And the height is how big is the pie. This pie is too small. You want a bigger one, just change it to a larger one, right? You can get as big as you want, as long as your screen can fit that, right? And again, one line of code, you can create this kind of nice chart. Just give it a CSV, and then Gmap will do the rest. This is probably too big, so 600, right? So now, like, which country has the largest forest cover in 2000? Russia, okay? And with that, now you can do, for example, let me see here. Oh, you can create a bar chart, okay? So if you want to rank them, you can do it like, again, one line of code, right? Russia, and if you have your mouse, you see the exact value, right? And it's so easy. Just under the hood, using Plotly. So Plotly to plot those. But you can give any CSV and then just call the pie chart, bar chart, and then pass in the input data and what column do you want to map, and it will do the rest. So this one here, so that you can see the trend, which country has the largest, right? So with that, now we can start doing like, okay, so what's the forest loss, right? If you're starting forest loss, you want to figure out, okay, which country lost the largest amount of forest since 2000. Then you'll be doing here, there's nothing different. It's all zonal statistics. Like give me an image and then give me a vector. So here, the tree loss, basically you have the data layer showing you earlier, right? You have yellow, you have a red color in here, right? So red color represents forest loss, and green, yellow color represents forest gain. So right now we are dealing with just this data layer, forest loss, right? And it's an image, right? Yes and no. So if you give me a vector, I calculate how many pixels with yes, it's 1, and then you can calculate the total of each within each polygon. So let me scroll back to here, and I'm going to calculate the forest loss. You can do the forest gain, the same idea, right? Boom, 1 second, and then forest loss. Okay, which one? Russia. Russia lost the most, right? And then the second one, Canada, Brazil, top 3, USA, Indonesia, right? So some of those mentioned like in the top 5. If you don't want to show the other, I can hide it. So now you can clearly see, right? So in total, since 2000, all the forest loss, Russia takes up 30%, and Canada takes up 15%, right? So you can see the like overall contribution. So if you're doing like carbon emission, you have given an image of carbon emission, then you can figure out, oh, okay, Russia or US like emit like 30% of the total carbon or something like that. You can imagine it's just an image, but you can do it for whatever data you want. Also bar chart, right? So you can rank them by country, right? Isn't it easy? One line of code, and then give an image, give a vector. This is the most basic. It's nothing fancy or nothing advanced, but it can answer some very basic questions. Okay, so we have the second exercise, and then after this we can take a break. So this one is asking you to figure out which US state has the largest forest gain or loss between 2000 and 2022. Earlier I showed you by country, right? But now I'm asking you in the US, right? I'm working at the USDA. I want to figure out like which state is doing good job, which one is not doing well, right? Which state like the bottom like lose the most forest? Then I need to talk to the state government to see like you need to pay attention, right? Or if you're doing great, okay, give him an award, like oh you're doing great, you get a forest gain, right? So you can simply just use Google search engine, couple lines of code, I can give you a specific result. And so if you really work for the USDA, next time if your manager talks to you, yeah, I know how to do that. Yeah, I give you in 2 seconds. Right, so now use this, I give you the asset and see if you can spend a couple minutes and figure it out.